7, 6, 5.
Hello makers, engineers, all electronic enthusiasts out there. This is a new installment of our Lab Talk series. I'm sitting in Aachen in the LabX installment. I'm your host for today. I'm Jens Nickel, the editor-in-chief of Elektor Magazine. I'm alone in the studio, but I'm not alone in the show. We have two guests, two colleagues joining me. On the left, that's Saad Imtiaz. Saad, maybe you can say something about yourself again. Some of the viewers may not know you already.
Sure. Hello, everyone. My name is Saad Imtiaz. I'm the senior engineer at Elektor. It's my third show here, and I'm really happy to be here today.
Yes, and I'm a little bit. Not shivering, but it's quite cold here in the studio. It's November, nasty November weather out there, and you are sitting in Pakistan. So what's the weather at the moment there?
Weather is a little bit cloudy. Today was a little bit foggy, but the temperature-wise, it's cooler for us. But for European folks out there, it's normal temperature. It's 18 degrees Celsius.
Okay. Yes, and on the other side of the globe, so to say, there's Brian T. Williams. On the right, Brian, how is the weather in South Africa at the moment?
A lot more bearable today. I mean, I'm surprised it's been hotter than Pakistan around here. We've had 33 degrees, which is, for our American friends, 92 degrees Fahrenheit. And at least today it's rained a bit, so our temperature is down to about 20 degrees Celsius outside.
Yes, but okay, you have summer now.
Correct.
Isn't it a little bit spooky to have Christmas in summer?
That's the only way we do it down here, along with our Australian friends and Chile, Argentina, Brazil, those guys.
Yes. Okay.
Although I have to say, the dress code for Santa Claus doesn't change, which is kind of weird when he comes and visits us down in the south here.
Okay. So he's sweating in his coat. Yeah. What do we have today in the show? Of course, we are always featuring one magazine edition, and this time we have the November-December edition in the newsstand sales already. The members also have it on their desk already. It's about prototyping and production. I can show it to the camera. And it's a folded cover, so it's not only the first page. You can unfold it, and here you see it in full glance. Inside also foldable, of course. Brian, it's generated with AI. I think they used, was it Leonardo AI for it?
Yes.
We already discussed in one of the last installments that you also have some experience with, I think, Midjourney. So
yes, we've been through so many iterations. I remember when DALL-E was the big hot kid on the block for generative images, but we've moved on to Midjourney, and now Leonardo did a great job on that cover. Okay,
what do you think will we have in 1 year? Do you think there will be even other illustrative generating tools? Like we see at the moment, we see a lot of new tools in text generating.
Yeah, it's getting crazy. There's something new every day, and I think by next year, that's so far off, but you can bet we'll probably have an animated cover, because AI is getting so good at making videos even out of memes, for example. It's crazy.
Yes, I've seen that also. Have you some experiences with video generation already?
No, that's the next field I want to look at.
Okay, we will talk about November-December edition. We will talk about some of the articles. Saad, we will come later to you. You have some experiences with PCB services. And yeah, Brian, you will talk a little bit about AI tools in the electronics lab especially. Yeah, but before we come to our other topics, let's come to the sponsor of this show. Yeah, you can see already a link here in that banner. This episode is sponsored by Hexter.io, from machine learning and edge computing to IoT security and automation. Hexter is the leading place where exploring tomorrow starts today. Hexter is organizing the Future of Resilience contest with Microchip. In this contest, participants are asked to use Microchip's AVR IoT Cellular Mini to develop and demonstrate a comprehensive system that reads sensor data and then creates an action to address a smart city scenario. Learn more about this contest at www.hexter.io/contest/AVR-IoT. I think you can just go to Hexter.io. I think they will feature the contest, so you will land immediately there. And we also have some giveaways. This time we have chosen for an ESP32 C3 dev kit M1. As always, you have an ESP32 with Wi-Fi functionality. On that board you have the usual two buttons, boot and reset, and you can power it through a micro USB connector. And I think there's also an RGB LED, which is quite comfortable if you want to show some status of your application. And we will give 5 of these boards to the first viewers who go to that web link and enter the code for today, which is just PCB. So yeah, just go to that link, enter your data, and then you have the chance to win one of 5 boards. Okay, we come again to November, December. So here, Brian, thank you for making that sheet. We have the cover again in full glance. And yeah, we also can see some of the topics featured in that issue. I don't think I have to say something about the Raspberry Pi 5. Again, we already discussed that in the last installment. Saad, you had a look on the Raspberry Pi 5 features. To AI, we come a little bit later, and you can also see we have one project on that cover sheet. We can have a look on that project. It is an Arduino Nano waveform generator. It's a HomeLab project we got from one of our readers. And yeah, we think it's a very nice combination of a digital and an analog part. We know that many readers love especially that combination because they can program a little bit, but they also have some analog part on the component level, which is not always the case. If you see projects out there, normally people, users look for modules where you have everything integrated, but here you can learn especially something about the combination of components. It has an programmable, so to say, programmable gain, and it has a low-pass filter at the output. You can generate up to, I think, 5 kilohertz signals. So yeah, that's already very nice for example, testing audio equipment. Yeah, you have sine, you have triangle, you have a rectangle, if I remember it right, and you also have noise, and you can also output PWM. So yeah, it's a nice gadget you can build and which can be also very valuable in your electronics lab. Yeah, this author hasn't built a PCB, he built everything on these boards, these versatile boards. It's nicely made, but yeah, we know from a lot of readers that PCBs are always very valuable. There you have more stable connections, of course, and that is already the bridge to Saad. Yeah, Saad, you know a lot about PCB services. And yeah, how can you get to PCBs? You also have written an article in this edition about PCB services. Yeah, and not only PCB services who build you PCBs or who make you PCBs, but also PCB services which are producing pre-soldered PCBs. Yeah, in some cases that's very valuable. If you have SMDs, very tiny SMDs, it's hard to solder it yourself because you have to have certain equipment. Yeah, Saad, I would say you can say some words about your article and what kind of PCB services you had a look on.
Sure, absolutely. Yeah, I have experience with these Chinese manufacturers, to be exact. They're really easy to deal with. Before you go for a PCB, I would highly recommend that go through a prototyping phase where you make everything on a breadboard. And once you're comfortable and you think, okay, this has all the features I need, that's the step when you make your PCB and find the manufacturer which is suitable for you. I have a little presentation prepared for us so that we can go over it. Let me just share my screen. All right, so yeah, this is the article I wrote, low volume board production. It actually basically covers what type of processes you're going to be falling into when you're going to be making a PCB yourself or assemble PCBs from a manufacturer. Me, myself, I've been working with, got my PCBs made from PCBWay, JLC PCB, and it's really easy. I'm saying again, it's really easy to get your PCB manufactured. There are certain things that you need to be taken account for when you're designing your PCB. Is that you go through their specifications or their limitations of making your PCB. So, for example, when I was ordering one of my PCBs, I made the vias to 0.1 millimeter, and their limitation was 0.2 mm. They couldn't make more smaller than that. Here's a guide which they share for with everyone, that how should your BOM should be, I would say described, everything from the package to the description to the part number, how should be your capacitor paste, how should be the silk screen and everything. It's a very thorough document. And if you follow this, I'm sure that you will be able to get your order done without any big questions.
Is it a sort of web form where you enter your components, or do you just upload an Excel yourself in a certain, and they describe how they want the columns of that Excel sheet?
Exactly.
Okay.
You're right. So you upload a CSV file, a BOM list, bill of materials, and most of the software PCB softwares out there, they make their own BOM list in their own format, but these manufacturers are really certain about, okay, it needs to be in this exact format. So the reference, then you give the description, then the part number, and they really make sure that you follow that guidelines. Otherwise, it's gonna just take some time. So yeah, speaking of prototyping,
sorry, do they have a big magazine with, for example, the standard components, or do they have to buy these components themselves from different distributors?
Exactly, I was just coming down to it. So component sourcing. Most of the times, if you're going for assembled PCBs, you can just give them the list of the components, and they will find the suitable, if they have the components available. If, let's say, there are some components which are not available with the PCB way or JLC PCB, they will say, okay, we will order these components from Mouser or DigiKey, and at that time, it's going to take, delay your timeline. So it's going to take more like 7 to 10 days. So I recommend you ask them, if you're on tight deadline, I recommend you say, okay, is there a Chinese substitute available for this resistor, capacitor, or this IC? Most of the times they do. If not, then you can also try to find some components from Alibaba and ship them directly to PCB way or JLC PCB, and it will save you a lot of time.
I see.
Yeah.
What is the size of, or the volume, so to say, what is the volume of pieces you would recommend for that kind of services? I think for one PCB it's not applicable, or is it? You can also
for one, I wouldn't.
Yeah. Okay.
Yeah, for one PCB, I wouldn't say that you just get your one PCB made from them or one assembled PCB. I would recommend, okay, let's go for 5 PCBs for a minimum, and get those 5 PCBs assembled as well. Because in testing, you can try to test different aspects of your PCB, or even give it to one of your friends for testing. So it's nice to have spares for your prototyping.
And what is the maximum volume? Can you also get 10,000? Is it possible?
I believe yes, I think it's possible, and even more than 10,000 it's possible with the PCB way, I believe. Okay, so speaking of getting our PCBs manufactured, we were working on this ESP32 energy meter project, and silent features are it's ESP32 microcontroller based on the ATM90E32S by Microchip. This chip is the energy metering monitoring chip, and the ESP32 is communicating to it via SPI lines. The main concept of this energy meter is to provide real-time energy consumption on your phones. So me right now, I don't know anything about how much power I'm consuming right now until I get my bill at the end of the month, or I go and compare the units. So this is a really nice, I would say, a tool to monitor your power consumption on the fly. Also with this energy meter, we will probably going to have a really nice web interface from on the ESP32 web server. It will also include 3 coil transformers, or I would say CTs with a single phase. We also have an option of having 3 phases as well, because it's a poly phase chip. This ATM90E32, but for simplicity reasons, I just kept it single phase.
Yeah, and I think we also already talked about that in one of our last installments. You will begin with the series to present that project in the guest edition. We will have a short look on it at the end of the show. And then in January, February, there will be a part of the series. We just edited it for January, February edition. And in March, April, there will be also an article.
Exactly.
Yeah. And yeah, for that project, you also used PCB service. Maybe you can say something about that.
Yes, absolutely.
Yep.
Yes, absolutely. So got this. I'm currently in. I got the schematic done, and you can get the sneak peek of this project before the magazine arrives to your door. So this is the block diagram. It's basically an overview of how everything will be working. Let's put this aside and talk about the PCB service. So I used PCBWay as the manufacturer for this, and yeah, it was a little bit back and forth between them because of some component shortages. When I designed my schematic, some of the components were available. All of them were available, and after 2 weeks, when I submitted the order, they were all out of stock. So then I had to come up with other components similar to them, and their support team is really nice. They were really accommodating, and they do ask important questions of your orders. They really try to make you worry free that hey, you're gonna get the right component installed and everything will be in order. So yeah, hopefully in 1 month I will be receiving my shipment, and I hope everything will be all right. Yeah. So let's just move on to the schematic of the energy meter. Here you can see the. Oops, sorry. I think it's not just zooming in. I think we're gonna stick it this way. So in the middle, you can see the energy monitoring chip, which is called the IC1. And on the right side, you can see the ESP32, which, yeah, you already know of. But in the middle, there's a new chip you see. It's an isolated, I would say it provides galvanic isolation to between the two circuits. So as you can see, the energy metering chip is getting direct AC voltage, and also the ground is connected with the neutral. And as I will be connecting my computer with the ESP32 for programming and debugging, there is a big risk that something might go just wrong. So to mitigate that factor, we're going with this isolation chip specifically designed for SPI line isolation. It divides both parts of the circuit with a different ground, with a different power supply and everything. So everything will be safe, but we'll find that out after a month when I plug this in. At the bottom, you can see the AC jack. We incorporated some MOVs, some varistors, and we're using the HLK M5 or 5M05 high-link module. It's a really small module. I think everyone has been, gone over it or seen it some projects, because it's a very compact power supply, and it also provides isolation through the transformers. And I use 2 of them to provide power to the energy metering chip, and another one to the ESP32. So that's pretty much it about this project, and hopefully more updates will come in the editions of Elektor Magazine.
Yeah, I think the readers are already curious about the progress of this project. There will be a housing at the end, and I think also a comfortable user interface. You're planning a web page or web server on that board.
Exactly.
Yep.
We will have a OLED display with this energy meter, where a person can see live energy monitoring or power consumption, and also we will have a web interface where a person can connect through his phone to the energy meter and see his power consumption anywhere in his house or anywhere in the world, hopefully.
Yeah, which is of course very comfortable. Brian, do we have some questions from the audience up to now?
No questions so far. Greetings. So hello to everyone who joined us, and thank you for joining us.
Yeah. Yeah, then I think we can come to you part, Brian.
Sure.
You may share the screen. We are switching back again to AI, artificial intelligence. And yeah, there is a big story in that November-December edition. It's from our regular author Tom Hanna, and Tom tested two powerful tools. That's Flux Copilot on one side and also Google Bard on the other side. And yeah, he tested how valuable are these tools, for example, finding components, suggesting components you need on your circuit diagram, putting components in your circuit diagram which you already have, and so on, suggesting configuration of certain components, and also writing code. It's a very interesting article. Yeah, I think in the meantime, these tools are even more powerful. Some of the errors, some of the hiccups Tom recognized, they may be fixed in the meantime. And yeah, Brian, I think you also had a look in these tools. Yeah, maybe you can say something about that.
Yeah, I have to say, for some reason, the generative skills of these AI tools are not as good when it comes to like actual practical use, as Tom said in his article. So he started off by going through Google Bard, which is a service a lot like ChatGPT, which is, you know, something I use every day. And it can also generate circuits and write code and so on and so forth. But he also used Flux AI. So in Flux, while you've been able to draw your own circuits and that sort of thing, as one would expect, now it has an AI chatbot on the side of the screen. In fact, Tom was chatting with it, and he was having some difficulty with both Bard and Flux in getting anything right. For example, here with Flux Copilot, I'll just switch the screen I'm sharing to show you a live version of Flux. Okay, that looks a bit better. So there you've got your regular circuit design that you might be doing. You've got schematics, you've got a PCB layout. But taking this board, this is an Arduino Maker Shield, for example, and I might want to add an oscillator circuit, just like Tom Hanna did. Mm-hmm. And I've asked it, what can I do to get an oscillator circuit? And he has a chatbot right here, and it's given me quite a comprehensive review. That's for diagrams. That's the part where it seemed to be battling. So I've asked it to create a 38 kilohertz oscillator circuit, because that would be the infrared remote control carrier frequency. And it's given me quite a comprehensive output. I'm sure I could get something done with this. That's for the electronics components. Tom, on the other hand, let's go back to that document. Back to his article. Nope.
Hello, Brian. You're back.
Sorry, something didn't like something there.
Yeah.
I'm trying to get back to Tom's article here. Okay, as you see, Tom had a bit of an issue in the first place, just getting it to respond. Initially, he didn't use the handle, and then he used the handle at the beginning of the sentence, then he used the handle at the end, and there was no reply, apparently. He's looking for an astable multivibrator, and then he used Google Bard here, and he seemed to have more luck there than I did in Bard, because he's actually getting some semblance of a circuit diagram, even though it's drawn in text. And then Bard offers you first draft, second draft, third draft, so you can try different things. Now, I went to Bard and asked for, this is the Bard intro screen, I asked for some circuit diagrams for an oscillator circuit as well, and this is the schematic it came up with. I mean, what it calls a schematic, but it's offered me a graph. I asked for a schematic, it gave me a graph. So my next question was, you drew me a graph of what should be a schematic, and then it tried again, but the response this time was not to draw anything. At first I saw the schematic and I was quite impressed. I thought, wow, you just came up. No. I took a closer look. No, you got that off the internet. So I could have Googled that myself. So mixed results, and as Tom says in his article, he wouldn't worry too much about actual electronic designers losing their jobs just yet. As I showed you in the live demo, it does give you very comprehensive text responses. But again, you can get this from ChatGPT. So it's a nice extra thing to have in Flux AI.
Yep.
But I wouldn't say it's going to design your circuit for you if you look at the simplicity of these circuits in Tom's article.
Yes, but you have to say that Flux is a program of its own, and that AI functionality is just a part of Flux. So yeah, of course you can also use Flux designing circuits on your own and use that artificial intelligence part as a nice add-on, I would say.
Yeah.
And yeah, I'm also curious how we stand in, let's say, 2 years with these kind of programs. Saad, in the preparation of this talk, you said there is some program which can really draw circuit diagrams with artificial intelligence.
Yes, I honestly I just forgot its name, but
Okay.
there is a program out there which still it's in the waiting list. I am in its waiting list, and you can actually get almost a complete circuit diagram from, let's say, a 555 timer for blinking an LED, and it will select the right resistors, your ratio and everything, and get your circuit done. And I believe it's coming to as an extension for other all of the PCB manufacturing tools, so like KiCad.
Yes, that may be a way to
And Altium,
integrate it in a normal CAD program. Yeah, we are waiting on really good AI programs, I think. But okay, they are on the way, and maybe we should feature this interesting topic also in the next installments. Maybe Saad, you can have a look. Can search for that program and show it in one of the next shows. I think it will be interesting for the readers. Brian, do we have some questions?
No questions yet.
No questions?
I'll just continue where I was.
Okay.
Tom's article was very interesting, and like you say, Flux is a great application on its own, but it's like they've bolted in an AI chatbot. I suppose it's trained more in the field of electronics, or at least I would assume so. With special prompting and different models. But it's the type of thing that I would just traditionally use ChatGPT with. I would have a separate window open and be asking ChatGPT the same things. But that's a brief overview of what Tom went through. As for me, I've got an article on getting it to help me with a physical project. I can solder, I can design boards, and I'd love to do more of what Saad is doing and get my hands dirty and actually getting PCB manufacturers to send me cool stuff. But I've done that before, and what I'm really not good at is the mechanical stuff, the stuff that moves. So I've delved into delve. That's a lovely word that ChatGPT loves to use, and now it's getting stuck in my head. I've got this Towers of Hanoi. That's a game that uses discrete mathematics. It's typically used to teach recursion in computer science. So I want to build one that is an egg timer, where a robot arm will take these disks and move them to a different peg, and it must take just long enough to boil an egg. Not that I'm likely to boil eggs manually often, but I just like the idea. I want to do something mechanical, and I want the robot to help me to make it. So it did come up with some good ideas, but these are generic ideas, and I had to dig in quite a bit deeper to get some more specific concepts. As you can see, that diagram is much like the so-called schematic that it offered me earlier in BARD. It really doesn't say much, and it's not that helpful. We tried again, and we used different prompts. Nothing there. So it's given me some ideas of what components I might use. And so that's where I am at the moment with that project. I've got an ESP board with an OLED, just because, it's not necessary to have the OLED. I've got a bunch of servos. I've got an N20 motor. Got a nice little robot gripper claw. But I'm still not exactly sure how I'm going to put these things together. It is a learning project, and as you see from the book example there, I enjoyed Dr. Gunther Spanner's book on Arduino and the way he constructed things. That is not exactly production quality, but it's a great start, and it's better than what I could put together on my own. So wish me luck in getting AI to help me with doing any of this properly.
Yes, and you are continuing with this project because it's your series and you have a regular installment in each of the editions.
Yes, and with any luck, it will end up being more than just a pile of components on my desk.
Yeah. And I heard from you that you are also working on, so to say, AI on the PC.
Yes.
Locally, that we have to say, locally, so not in the cloud. Can you
yes,
already say something about that?
I can't say too much about it. I've been trying different models and different open source platforms. For example, earlier versions of ChatGPT have been open sourced, and you can install them locally on your PC. Good to have a good graphics card. A friend of mine has an RTX 4090, which was a bit overkill for this. That costs about €2,000.
Okay.
But I managed to get myself an RTX 4070. It does the job a little bit slower, but you can run chatbots locally, and I'll certainly be covering more of that. And not just that, I've run other kinds of things. For example, Whisper, speech to text.
Okay.
You could just take this video, for example, that we're doing right now, pump it through Whisper on the local machine, and it will come out with a great transcription, even if I'm mumbling now and then and stuttering, and it will get what I'm saying, just like hopefully you guys get what I'm saying. And of course, I'm keen to work on speech to text. That's the other way around. And then we've got a computer that we can talk to using our voice, and it can talk back using voice, just like in the science fiction movies.
I see a lot of interesting experiments for the next shows already.
Oh, yeah.
Yeah,
for sure.
I think we are nearly at the end of this lab talk. Yeah, let's come quickly to the next edition. Saad, yeah, we already said you are working on a energy meter with ESP32, and that brings us to the guest who edited with us that next edition. It's our guest edited edition together with Espressif, and you will find a lot of interesting articles around ESP32s. Especially, we have there are many projects also dealing with the fascinating topics as language recognition. We have song recognition, we have facial recognition, but we have also projects without AI, for example, picture frame, which can be remote controlled from all over the world. And we have, of course, interesting background articles, how to program firmware safely and. This edition is currently at the printer, and you will find it next month, beginning of next month, at the newsstand sales, and you can also order it, of course, in our shop. And more about that we will have in the next show, which will be, I forgot the date, I have to admit. It's, I think, January the 23rd or something like that. Please just go on Elektor Lab Talk, and then you will find the exact date. It will be, again, I think, a Thursday this time. Yeah, you can see the URL at the top, Elektor-Lab-Talk, and there you can find the next date of the installment and the program. And most likely we will also have an engineer from Espressif in that show as a guest. He will also talk a little bit about his work, which is very interesting, I think. And yeah, we will have also a partner show, that's Elektor Engineering Insights from Stuart Cording. Yeah, you can also see the next installments when you go to the second link. But a very interesting announcement is also the next webinar, and that's already next Thursday, when I calculate it right. So Thursday in a week will be December the 7th, also at 4 p.m. CET. And yeah, the topic will be our labs page and how you can put projects yourself on that labs page. I think, Saad, you will participate, and also your colleague Jean-François from our Elektor Lab team. And they will show you everything, how to upload own projects. Yeah, I think that's the end of this installment. Yeah, we can all have our evening. And yeah, Saad, I think, how late is it already in Pakistan?
It's almost 9 p.m. here.
Okay. Then many thanks for joining. Yeah, many thanks for watching our show, and yeah, until the next time. Bye.
Cool. Thanks so much for having us virtually, Jens. Okay.